I got my coffee. Today is going to be a major day. We are going to be forecasting this storm right to the end. Oh, by the way, winter forecaster Stephen Boyle. Winter storm warnings in effect for many states. And, this is going to be historic. Blizzard warnings from Washington up to the New York City metro. Yeah, this is something that you don't see too often, and I have never seen a storm of this magnitude with such uncertainty. What, 36 hours out? It's unheard of. It's unheard of. Winter storm warnings, and there is a blizzard watch for southwest Connecticut. Winter storm watches for coastal Connecticut, all the way coastal Rhode Island, all the way into southeastern Mass. May need to even be extended north. We'll have to sort of see what happens. Here is the model imagery. I am concerned, and there's a reason why I'm concerned. I want you to notice how this storm is moving. It's not moving due east. Look how it's moving northeast. I don't know what to say. If I were to look at this without looking at any models whatsoever, I'd be saying this is going to be a major snowstorm from Virginia points north. I mean, you can't deny the models, though. But if there's going to be an eastward push, it would have to happen within the next 4 to 6 hours. And it would have to be pretty significant. I want you to notice the track so far has been something like this. Actually, it's even a little more north than that. It's been something like this, because the low right now is right here. So, in order for this to go east, and for it to miss southern New England and New York City, it would need to exit right here. Where are we having this right now? It's up here. Mountains of Tennessee is where the low is centered right now. So in order for this to exit, where we will not get any snow or very little from points north of New York City, we need this storm to go east in about 4 to 6 hours. If it doesn't do that, if it continues doing this northeasterly direction, or not northeast, northeasterly is what's going on here, it would need to do something drastic. Right now, looking at this, this is current data. I'd project this to be exiting somewhere in here, which is much farther north than what many models are showing. And this would put all of southern New England, or at least a good chunk of southern New England, in the game for major snows. This is current model. This is current. Right now, it's moving northeast. So let's look at the models here. The Euro has the low exiting right here. So that means the storm would take a track like this, which is possible. Okay, now here is the situation. The Euro actually has the center of the low right in here, so it actually would be taking a track like this. Okay. Again, it's possible. There's not much of a change here between the different models. Okay. So you have your low right in here on the Euro. This is the GFS. It's slightly to the north. Notice it's almost right in here. See that? So from here to here, that's virtually a pinprick. But as I mentioned, if it exits right here, it'll be significant. It will be significant. Now I have a problem with the American models. Okay, my problem with the American models is notice how there's a bunch of energy all over the place. This indicates that the model is clueless. Okay. What this signifies is when this happens, the low tends to elongate. And you end up getting a bunch of little lows. Okay. And what will end up happening is one of these will strengthen, and what will end up happening is you'll get this huge, huge piece of convection out over the ocean. Sometimes it's on land, but with this storm it will be out in the ocean. Okay. That's what we call convective feedback issues. It's when the model is basically uncertain of what's going to happen. And this is being shown throughout every single model, basically. Not this convective feedback, but this uncertainty is being shown within all the models. The NAM. It's a little more scented, but it still has energy all over the place. There's some here, there's some here, there's some all the way up here. I mean, it doesn't know what it's doing as well. Okay. There's energy streaming all, so it's all over the place. Okay. So we have to, again, watch future models and what happens. But more important than the actual low itself is energy to the north. We have to watch this energy, and we have to watch this in here. Those are the two things we need to watch. This, how far east this is, will dictate how far east the high pressure is. If it's further to the west, guess what? The storm goes further north and west. So here's the Euro. It's got it scented up in here. Here's the GFS. Notice it's much further to the west. Much further to the west than the Euro. The center of that is right in here. The Euro has it right in here. But look at that. That's virtually no change. Pinprick. And that makes the difference of this being more to the north and west or more to the south and east. Here's the NAM. The only difference between the NAM and the GFS is that this high is slightly weaker. That's the only difference. And the difference between the NAM and the Euro? Virtually nothing. Virtually nothing. So what will end up happening is this, which is called the confluent zone, in the Euro is stronger. I want you to look at this. See how you've got all these oranges and yellows? Look at the NAM. It's more north and west. Okay. Especially in here, you can see how it weakened a little bit. Here's the GFS. Notice you've got these reds. So this confluent zone is much stronger. That means you're getting more dry, cold air to the north and west, meaning you don't get much snow. That's the only difference. So we have to watch this. These little details make the difference between you getting almost nothing to perhaps, in some cases, over 2 feet in some regions. At least over 6 inches. This is the euro. You have your low scented, your actual surface low scented right here. You've got light snow extending all the way up here. You've got moderate snow extending through Hartford up into the Boston area. So granted, it is further to the north. Okay. Major winds as well. Major winds. GFS. Notice I said about an elongated low. See how it's got this eclipsed. It's like this eclipse. It's an oval. That's what this means. That's what I was talking about. So instead of having a band, a storm like this will have a big band. It will have a band, and it will be centered on the northern side of the storm. So instead of having that, you've got these random pieces. You've got a band here, you've got some bands out here, and most of the bands are centered offshore. Okay. Which with a storm like this, that doesn't really happen. And that's what we call convective feedback issues. Okay. But in any case, there's going to be an eye with this thing. Oh yeah, there's going to be some major coastal flooding. There's going to be, in some areas, close to hurricane force wind gusts. This is going to be significant. Definitely going to be significant. Here's the NAM. Notice it does have a band. So that's one thing going for the NAM. But the problem is you've got all of this out here that is building on top of each other. All of this precipitation building on top of each other. So that is also a concern with this run of the NAM. Okay? So it is also having convective feedback issues as well. So although it's further to the north, and although it may be showing something, it's still got these issues. But granted, there is an eye with this thing. Major, I am saying major winds. Blowing and drifting snow, it's just full-blown blizzard. And remember, the difference between this and this is this guy up here. Here's the euro, here's the NAM. The euro has its centered right here. The NAM has its the NAM has its centered here, the euro has its centered here. Or I'm sorry, the euro has its centered here. The NAM has its centered here. So this is the NAM, this is the euro. Euro is further to the east, NAM is further to the west, and slightly weaker. See how it's a little weaker? Notice how it's a little stronger back out in here. NAM is slightly weaker. Not by much, though. Let me tell you, this is not much, but it's enough to make a huge significant difference for snowfalls. Thus, this confluent zone is a little weaker on the NAM and a little stronger on the euro. I want to look at the what we call them the Schreff model, the Schreff ensembles. These are really good because ensembles are a range of models. They're short range models. We are in the short range, folks. This is not far out. You know that. 36 to 48 hours approximately. Short range ensembles, really, really nice because they paint a picture. Okay. Now, usually within this time frame, you've got a good solid range. Usually it's like most of the Schreff will be like, if it's going to be like, if some models are indicating 3 to 6 and if some models are indicating 8 to 12 or whatever, the Schreff would be within within its own little range. Let's say one model is indicating 3 to 6 and another model 8 to 12. The Schreff would be somewhere in, I don't know, 6 to 12. Okay. It would be in a range that's normal. I want you to see these ranges though. This is in New York City. This up here, 36 inches. This down here, 4. So look at this range. It's huge. It's huge. So this is why bust potential is major. It's really major. This is where a lot, now notice most of them are up here, but there is several down in here. This is about, we'll say 11 inches. This is about 16. Okay, so most are, there's several scented in here, but look at where most of them are scented. You've got your mean at approximately 21 inches, with this one being approximately 26. So you're talking approximately 2 feet of snow in New York City if this was to verify. You've got even a couple up in here. One showing about 31 inches and then one here showing 36. So if this were right, we'd be talking 18 to 24 inches in New York City. This is Boston. This is where it gets really insane, the swath. This is 30. This is 0. This is a significant swath for this close in time frame. Significant. Now, granted, most are scented from approximately 20 inches down to 0. But even still, that is significant for this close in time. This is unheard of, folks. This is unheard of. Usually models this close in are very locked. Now this is locked in Philadelphia, Point South. But this is uncommon once you start. This is still uncommon in as far as this when it comes in terms of this storm is concerned. This is western parts of Massachusetts. This is about 28 inches. This is 0. So still, the model swath is significant. It's significant. And most of the models are scented from approximately 24 to 0 inches. That's significant. That's significant. So, what's the general gist of my video? There's so much uncertainty. The high being scented just approximately 60 to maybe as much as 100 miles to the west will mean the difference between some folks getting no snow, and over 6 inches. That's what this is indicating to me. Now, before I get into my snow totals, this is the blizzard of 1983. Now, granted, no two storms are exactly the same. This storm I'm taking into, perhaps taking it slightly more into account, because the major reason I'm doing that is because this storm models approximately within this time frame to a little bit before this, we're showing coating to an inch most of southern New England. What ended up happening? Well, you can see for yourself. Some areas in here picked up close to 2 feet. Yeah, this was major. Notice the major snows north and west of Washington. It's gonna happen. This is gonna happen with this storm. It's locked and loaded here. Now, granted, I don't think it's gonna be as much into these regions, but you never know. With this storm, you never know. But right now, I don't think there's gonna be much into, especially these regions up in here, southern Vermont, southern New Hampshire, but who knows? This is the blizzard of 96, and this is interesting because it's actually showing pretty much, to a certain degree, what I'm thinking south of Philly. Okay. I'm thinking this is going to be these regions in here, at least 18 inches. I think 24 to 36 is very likely. Someone in here is going to get blasted with perhaps close to 4 feet. Mountains of West Virginia. Notice if this is right, with this blizzard, there was about 2 feet of snow that fell in New York City, and notice southern New England got a major blizzard, a foot plus. Actually, notice there was 2 feet plus in here. There was 18 inches, all of these regions in here. Something also that is interesting, there was a major cutoff. From here to here, this is 1 inch up here, this is 18 inches. This is a huge cutoff. And this is my worry. I'm not forecasting that, but I'm just showing you what is on the table. But this is my forecast right now. Notice I have major bust potential in this circled area. Before I get into amounts, Philadelphia point south, my forecast confidence is 95%. Between approximately just north of Philly to just about New York City, just south of New York City, my forecast confidence is about 35%. New York City points north 25%. I changed my snow totals slightly from yesterday. I was going to do a video yesterday, but I'm glad I didn't. Yesterday, I had a coating to an inch right in here. Today, I changed it slightly to about 1 to 3. I'm going to be doing a video later. Perhaps it's going to have to change a little bit. Right now, here's what I'm thinking. 24 to 36 inches plus into the mountains of West Virginia. Washington, D.C., 18 to 24 inches. You're working your way into New York, Pennsylvania, that area, Lancaster. I could see as little as 14. I could see as much as 2 feet. Working into Philly, I'm liking 12 to 18. My good friend Lenny out and my good friend Dan at Ruckus, 12 to 18. Let's see here. New York City, 8 to 12. Again, as I showed you, it could be more than that. My good friend Radek, I'm liking you're on the border of 6 to 8, 8 to 12. Could be more than that. Southern Connecticut, I'm liking 6 to 8. Hartford right now, I'm liking 3 to 6. Boston, I'm liking about 1 to 3. Myself, I'm liking about 1 to 3 with my good friend Pat as well. We're looking right now at 1 to 3 for us. My good friend Braden, about 6 to 8. I could see 8 to 12 easily. Northwest Jersey, I'm liking about 3 to 6. Poconos, I'm liking 6 to 8. Richmond, right on that border, but I'm thinking 6 to 12. I'm thinking 6 to 12. I could see a little less, but I could also see a little more than that too. What am I? Oh, State College. I could see up to 8 inches. I could see you getting up to 8 inches with this. Pittsburgh. It's tricky, but I could see it coating to an inch. I could see 1 to 3, maybe even nearing 3 to 6. Let's see here. Who else am I missing? Long Island, 8 to 12. Cape Cod, 6 to 8. Perhaps a little less if this storm still does a northern jump. Albany, right now, 0 inches, but I could see easily, it's possible, about an inch. Major bust potential in here. Notice a lot of us are in that. Major bust potential. That's my thoughts right now. Questions, comments down below. I'll be back later this evening.